welcome today, because again, this is ELI5 physics. Today we're going to be continuing our discussion on forces. So last time I introduced the four main forces we're going to be dealing with: the normal force, the applied force, the force of friction, and the gravitational force. And our main equation, the net force equals ma. Today we're going to be dealing with a more concrete example, and I'm going to be explaining some of the equations we use with all of these. So the most important equation we have is Fg, because every single object you're going to deal with has the force of gravity applied to it. And Fg equals the mass of the object, so its mass, not its weight, mind you, times gravity, which, like we've discussed previously, is 9.8. So let's say we have our block, right? And it's being pulled down by gravity. Well, the force of gravity up here is going to be mg. So that's going to be mg. And let's say the mass of this block, so m is going to equal 1 kilogram. Kilogram is the standard unit we use for mass. So this block, gravity is going to be applied to it, 9.8 newtons. Using newtons as our standard unit for force. So then, the normal force is always the sum of the forces opposite it, because it's what keeps it from moving down. So the normal force right here is also, so it's the sum of the opposite forces. So the sum of all the opposite newtons. So in this instance, the normal force pushing up is going to be equal to the 9.8 pushing down, because the box wouldn't be moving on the table. So it's 9.8 newtons as well. So those balance out, cancel. The box is not moving up or down, which would be weird if it was just sitting on the table. The applied force is a number. That's how much we're pushing on the box. So we have this eraser, how much we're pushing on the eraser. So there's no real equation for that. Let's say in this instance, the applied force was 2 newtons. So there were 2 newtons going this way. And then the force of friction is the interesting one. So friction is equal to mu. And friction is fun. So F, the force of friction, is equal to mu, the coefficient of friction, which varies surface to surface. If something is rugged, it's got higher. If something is smooth, it's got a much lower coefficient of friction, times the normal force, which is the opposite of all the forces below it, which we've talked about previously. So in this instance, let's say that mu equals, let's use a nice number, let's use 1. It doesn't have any units because it's not really a value, it's just the ruggedness of the surface we're pushing on. So in this instance, mu n would be 1 times 9.8, so then it would be 7, 9, I can do math, 0.8 newtons are pressing back that way. So for friction right here, it's 9.8. And so because the friction of the table is greater than the applied force, I could be pushing on this box, but it's not going to move because there's too much friction. It's too stuck there for it to move over. It's like pushing on a heavy thing and it not moving. That's because friction is too high, not because of the actual weight of the box. Though friction is clearly affected by the weight of an object. And that's all we're going to be talking about today. Thank you.